And hello. Oh, it's very dark here. Just a sec. Let me open a curtain. Oh, that's better. We'll be able to see me now, which may or may not be a good thing, but it'll be the truth. So howdy, folks. Welcome to Unhindered by Coding. Second go of today. This is episode 22. If you've been following along, I've been streaming Tuesday and Saturday mornings, working on a project, Rust and U WebAssembly web app to batch archive GitHub repositories. And as an experiment that I think will run through September, we're going to expand this to 4 streams a week instead of just 2. And the other 2 streams are Tuesday night from 7 to 9 p.m., where we are doing evolutionary computation in Rust. And then today, Saturday, from 2 to 4 now. This is all Central Daylight Time. Where we're using Rust to build some tools, some labs. So here at University of Minnesota Morris, we teach, as part of our computer science program, we teach a course called Systems Practicum, which is a lab systems course. So all programming, 2 lab meetings a week, build a variety of things related to systems in some way. And I'm going to rebuild some of those in Rust to see what that's like, and possibly create some new labs using Rust. So that's the idea, and we'll see how that goes. We're going to start today. This is the first days of doing that work, and we're going to start with using Rust to build an Echo client and server. So an Echo server is a tool that has historically been used in various situations usually to do things like test networks. So it's a simple service that receives content and echoes it back. So it listens on some port, and whatever comes in on that port, it just turns that around and sends it right back to you. So if you have an Echo server running somewhere on a network, you can test that the network is working by sending that Echo server some data, and you get a pretty low-level test then of whether the network is behaving properly. Because if you get the same data back, life is good. And if you don't, and you trust that the server's working, then there's some sort of problem on the network in between. So we're going to start by building an Echo client and server in Rust, initially without threads, and then we'll add threading, which is particularly important on the server side, so you can handle multiple connections in parallel. But also there's an interesting potential, at least when doing this in Java, there's an interesting place where threads can simplify might be a strong word, but I think in some ways simplify the logic of how the Java code handles what's going on. Having not written this in Rust, I don't really know if that is going to be an option, or is going to make as much sense. We'll try it. We'll see what happens. So, we're going to build an Echo server. So, let's see. There we go. I've gone ahead and created a project, and this is on... where did that go? Hello. Did I not? Oh, maybe I didn't. Repositories. Echo. Oh, so I don't know if I haven't pushed this. What? Let's push this. Boom. P. Go. Reload that page. There we go. So if you want to follow along, the address for the repository is there. So I've created some structure. So I've put both the client and the server in the same GitHub repository on the assumption that that'll make more sense. And in each one, I've set up a basic Rust project. So I have a source directory, a target directory, get ignore, cargo lock, cargo toml, and a readme. And here's the readme. So we're going to start with the server. Here's a readme on the server. And this is a simple implementation of an Echo server without threads. We're going to listen on some socket, on some port, and send back whatever we receive. And at least in Java, there's a tricky bit with this where the naive way of handling the sockets using text processing tools like readers and writers breaks if you send binary data. So if you send an MP3 or a JPEG or an executable, some kind of binary data, it gets mangled when it goes through the text processing stuff in Java. That's all handled quite differently in Rust. And so I don't know if that's going to be an issue or if maybe Rust will just like get it right the first time and there won't be an inclination to try to do text processing on it. I don't know. We're going to find out. So, and comments, questions, suggestions, always welcome. Definitely feel free to speak up if you've got any questions, concerns, ideas, etc. Okay, let's move on with this puppy then. So I want the source main. There we go. And we just have the hello world. Plus I added a bunch of Clippy warnings because I like having really pedantic warning structures. That makes me happy. Sorry. So we've got that going as well. So we need to open some sort of socket and listen on it. That's sort of the first key piece here. And there are various socket libraries we could work with. And this is not something where I have spent a bunch of effort looking into, but my sense is that socket 2 is a reasonable choice. So I was thinking of going with that. But if somebody's got like a different suggestion, by all means, holler. Because I do not claim to be an expert on all the options floating around. So cargo, where am I? Am I in the server? Yeah, add socket 2. You know. La 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 la. Okay. And now that should have updated my cargo toml. Yep, we now depend on socket. So that's exciting. So we ought to be able to do sockety things. And basically we want to bind onto some port and listen. So this, I think, is what we want, this socket.listen. Let's go to socket and listen. What does that do for us? So mark a socket is ready to accept incoming connection requests using socket.accept. An error will be returned if listen or connect has already been called on this builder. So actually we have to have a socket in place. Oh, interesting. And so socket new. Oh. So we're going to need a socket new thing. New. Takes a domain and a type and a protocol, which is optional. So we don't have a protocol we care about. A domain, I'm not sure what's going on there, and a type, I'm not sure what's going on there. So we're going to have to figure some stuff out. Domain, looks like we can specify things like IPv4 and things like stream. Oh, interesting. So let's find out what domain and type are. Domain. Around an integer. So we have domain IPv4, IPv6. Do I care here? I don't know that I do, to be honest with you. I guess the server doesn't ever specify a domain, an IP address, or anything like that. So I don't know that the server cares. When we run this on campus in the lab, I'm not sure if the university has IPv6 up and running. So I don't know if IPv6 would work. I'm going to try it with 4 for now and make a note that I might want to come back and explore 6. And then type, what are my options here? Specification of communication semantics on a socket. Oh. So we've got stream, dgram, datagram, seek packet, and raw. So I think we're doing TCP here. So we're going to just say stream, I think is our type. Okay. So I think we can make a let socket equals socket new. Let's import that so we know what's going on. And now new is going to need to take a domain, a type, and an optional protocol. And I don't think we care about the protocol. So domain IPv4 and type stream. Now that's a result. So we're going to have to think about what kinds of errors that we can get and how to handle them. And I do actually want to deal with that. So result socket. So actually no, what I wanted was this result here. No, interesting. Okay, I did want that. And then it's a specialized result type for errors, IO errors. Okay, so this is going to be a special type for IO errors, and it can be all kinds of things. Well, that's not super helpful. So I really wanted to know what kinds of errors this can throw. Well, maybe I don't care that much, because maybe I just want to, like, if it throws an error, die. Or maybe my main should return a result. Ah. Maybe that's a thing to do. And then this could be just question mark here. Aha. Result empty or error. And I want that one, I think. And now I think I can just question mark this puppy. No. Well, actually, it knows that that's a socket now. Why are we fussing? Oh, yeah. It expected another argument, and I can just say none. So the third argument was an option, and so an option's either a some or a none. So I can just specify none to say that I don't have a protocol. And I assume that if we come back here, yeah, that's what they've done. Oh, and they've also got a question mark here as a way of just like making that go away. But now we're not happy. We're not happy because this explicitly so we aren't returning. We don't have a return. Do we have to have one? That seems weird. Oh yeah, we're going to have to, because that's a result type, we're going to have OK and empty as our end game, right? Oh yeah, I got semicolon because it didn't return it. Okay, so that actually constructs the socket. Huzzah! Now we have to, let's get rid of this hello world because that's just not doing us any good. Now we're going to say socket.listen. And what did that look like? It socket.listen marks the socket as ready to accept incoming requests using socket accept. Okay. So we don't actually do anything yet. We'll have to call socket accept to get something. Oh, there's a TCP listener socket. Maybe I should look at that as well. Because that might be useful? Don't know. Okay. Well, let's say we're going to listen to a port. Socket.listen. And we need a port number. I'm just going to make something up as a random port number. We probably ought to make that configurable on the command line. Make this configurable on the command line. So we may need to come back to that. But for now, that'll work. And now it said we could do socket.accept. So what does that do for us? And do we prefer to have accept a new incoming connection from this listener? So it uses accept for a new incoming. Okay, I don't think we care. So I think we can just say accept and not worry about it. So that returns a socket and a sock adder. But we also want to figure out what is this TCP listener thing. Rust TCP listener. TCP socket server listening for connections. After creating a TCP listener by binding it to a socket address, it listens for incoming TCP connections. These can be accepted by calling accept or by iterating over the incoming iterator returned by incoming. Okay. So this would be another way to have done the setup, which for us probably would be just as simple and wouldn't involve bringing in another crate. And I don't know that socket 2 is going to bias anything in particular here. And then for stream and listener incoming. Interesting. So then that just, as long as we're getting connections, handle them. And incoming, presumably, it never returns none. So it's essentially an infinite loop. Oh, nice. Actually, I like that. I like that's a nice way to do it. I think maybe I'm kind of thinking that this is simpler, and would be a pretty nice way of dealing with it. And we don't really need socket 2. I think that's true. I think I'm going to undo the dependency on socket 2. And Lord only knows what that's going to do. Well, actually, okay, just a sec, before I get too far down. Rust difference between socket 2 and socket. Don't know. Not obvious unless there's something here. Using advanced configuration, but see, I'm not using any advanced configuration options. So I think all this domain stream stuff is, so if you don't know how to create a socket using libc system calls, then this crate is not for you. So I don't think we need socket 2. I think we can do fine without it. And so I think we're gonna like punt this, and we're gonna sure. So just grab all this. Wah, wah, wah. And we'll put all of this here. Okay. So we ought to be able to import that. And we'll have to define handle client. Now, does bind need an adder? Can I provide a 2-socket adder? Wah, wah, wah. There we go. Do I have to provide an IP address, or can I get away with just providing a port? Looks like I need to provide an IP address. So I have to sort of have localhost explicitly. Oh well, such is life. Which I guess is fine. I mean, we're listening on this machine. I didn't want port 80. We'll do this again. And now I need to have my to-do again. Let the user set this port via the command line. So we'll have to do that. And then we'll get incoming connections. and then we will handle them. Now they call this a stream. Yeah, that's reasonable. Echo client's probably not a great name. So let's say echo stream. Boom. And then, yeah, we now need to define echo stream. We're going to deal with that question mark. So this is a TCP stream. In input, and we're gonna return nothing because we're just gonna output stuff. Oh, and we'll need the socket here in a bit, but we'll deal with that unless it's in the stream somehow. So let's see, let's see, stream incoming. Come on, there we go. Incoming turns an iterator of incoming thingies, and what is that? So incoming actually I'm confused because this says this returns an incoming and we're getting this is a TCP stream. If I change this, that's result TCP stream error. So it's like somehow I'm not sure how these are possibly. Let's see, what we saw that this was a result TCP stream IO error. So there could be an error here. And if there's an error, well, I guess we just want to return it for now. I feel like maybe we might want to console log something. And this could be a place where using sort of a nicer error handling system would potentially be useful, because there are quite a few possible errors here, and using a system that lets you kind of capture and handle those in a more structured way might actually be pretty useful. I'm not going to deal with it right now, but we might come back to it. If we get an error type in stream. Okay, so input TCP stream. What can we do with a TCP stream? That's a great question. And I don't know the answer. Let's see. I've got, this is all socket 2 stuff, which I'm not dealing with anymore. TCP stream, is that down here somewhere? No. Oh, there it is, yep. Okay. So a TCP TCP stream data can be transmitted by reading and writing to it. Oh, okay. So it has everything we need for both reading and writing. The connection will be closed when the value is dropped. The reading and writing portions of the connection can also be shut down individually with the shutdown method. So we can write and we can read. And if we read, it looks like we have to pass a something that is probably a buffer. I'm guessing. Where did read? Where is this coming from? Probably one of these guys, I'm guessing. Yeah, probably. What are these two reads? TCP, impl read, and struct TCP stream. Oh, impl read and impl read one. Why two of them? That's weird. Impl read for TCP stream, and for reference to a stream. Well, I think we have a stream straight up, so we don't need to worry about the reference side of things. Yeah, I think we've got a stream, and we can hand ownership of the stream to Echo Stream because we don't need. Our main doesn't need to ever deal with that stream again. And so we don't have any reason to pass it in a borrowed state. We can just pass it as owned and not have to worry about it. Okay, that makes sense. So we read, pull some bytes into the specified buffer, returning how many bytes were read. Okay, that's plausible. Read vectored reads into a slice of buffers. I don't think I care about that because I think I'll just have a buffer. Read to end. Not a good choice because we might get we would not send anything back until they have ended their stream, and we probably don't want to do that. So this is interesting because this is where in Java there's a temptation, especially if you just read the internet, to quickly convert everything to strings, and then you get into trouble. Whereas if we stick with U8s, we're basically just reading raw bytes, and that's probably better. Now there's an experimental about reading into a buffer type, but we don't have experimental, so we're not going to do with that. Transforms this read instance to an iterator over its bytes. Is that possibly useful? Maybe. Let's see, it says read more. Let's go read more. Transforms this read instance into an iterator over its bytes. Actually, we probably don't care because we're just going to turn around and write them back. And we could write the whole buffer back and not really have to worry about it. Yeah, there's probably no reason to split them up into bytes if that's not necessary. And I think we can just read into a buffer. Let me actually look at this. So we get OKN if we did read something, and N is going to tell us how many bytes we read. If N is 0, we could have reached the end of file. Or the buffer was 0 bytes in length. Well, we're not going to do that. So this is probably the more likely scenario. Callers cannot rely on N less than or equal to buff len for safety. But it says here, if the return value is OKN, then the implementations must guarantee this. And we're not implementing this, we're just using it, so I think we can assume, but it says that we cannot assume that, which seems weird. Well, I think we can make a buffer, read from it, and then write it back. I think that's the plan. So let's do that. Let's specify const buff size, we'll call it buffer size, u size, let's do 128 bytes. I don't know, that's just a kind of a random number, but now then we're going to say input dot read, and that takes our buffer, which we need a buffer, so we'll have to make a buffer, and that will be let mute buff equals and it was U8 that just sets it all to zeros, so 0 buffer size. Yeah, so now we have 128 I32s, but we don't really want them to be I32s, I don't think. Don't we want them to be U8s? Probably from, yeah, it's an array of U8s. So I suspect if I leave it alone, is that what has to happen? No, I wanted this one. Yeah, so we have to say immutable reference, because we're passing a reference, so because we're not copying the thing, and it's immutable reference because we're going to read into it. And that turned it into a U8. Hot diggity. Cannot borrow input as mutable as it is not declared as mutable. Aha. So this is going to need to be mutable. so that we can, because we're going to modify the TCP stream as we read from it. Yep. And now we're gonna, so now we read, and now our buffer has, input returns the number, right? Yeah, so we need let n, that's probably part of what this yellow squiggly, aha, yes. So we're not using the result, and it's warning us about that. How smart. Let numRed bytes equals, there we go. Now we could have had an error. So again, if we do result error, then we can do that. And then if there's a problem, it'll just kick back. I guess we'll say okay down here. Why are you grumpy? Oh, I left the semicolon in again. Same problem. Okay. So now, if this fails, so we probably want another to-do, handle the error case here. So I definitely think we're going to need to look into one of these error handling libraries to do something kind of decent here, because this looks kind of confusing. So now this really needs to be in a while loop, because we're going to need to keep doing this over and over again. So is this really just loop? And then if numRed bytes equals 0, return okay. And that just goes away? Yeah. So now we get the error case. If something bad happens here, the question mark would return the error variant of result. And if we get to the end successfully, we'll return the OK variant of result. Otherwise, it's just going to spin around. Cool. This was fun. So now, at this point, we have more than 0 bytes, so we want to write them. So actually, this isn't really input. This is the full stream, so it's input and output. So actually calling it stream is probably a better name, because now we ought to be able to say stream.write. What are my options here? That's interesting. Write all, attempts to write an entire buffer into this writer. That seems like that would be what we would want. What is write? Oh, well, okay, fine. Let's go back here. Where was read? read was here. No. Read was, yeah. Read was, no. Read was here. So we want write. Write takes a buffer, writes a buffer into this writer, returning how many bytes were written. Now, that implies that you might not have all the bytes written. Each call to write may generate I/O error. If an error is returned, then no bytes in the buffer were written. Is not considered an error if the entire buffer. So when would it be the case that not everybody would get written? Attempts to write an entire buffer to this writer. This will continuously call write until there is no more data to be written or an error of something other than interrupted is returned. That seems like that would be what we want. I don't really want to dwell on partial writes if write all will just do the work. So I think write all, taking our buffer, and I think we can just say question mark at the end of that. And now, oops. We need to send a reference to buffer. And we also should, oh no, it returns result. So it returns nothing unless there's an error. So we're okay there. So we should probably to do handle the error case here. So then that's going to write everybody out, come back to the top of the loop. We will read again. We will check to see if we got 0. If we didn't, we will write again and continue. So fingers crossed, that would actually be a thing that would work. Go away. Now there's a couple of warnings. 32. Oh, it wants a semicolon here. And 18 echo stream. Unused result that must be used. Oh, echo stream could be a, yeah, okay. So we actually also have to do back from echo stream. So we've got 2 question marks there, and we really ought to deal with both of them. So that's reasonable. Okay. So Clippy's happy. Let's see if we can, that wasn't what I meant to do. Here we go. Cargo run. And it's running. And I should have had another terminal set up, but I didn't. And where am I? Oh, I know, that's the problem. So I want to documents. You're programming. Rust echo client server echo server. There we go. Not that all of that was probably strictly necessary. So we ought to then be able to just, I think, telnet. Do I have telnet on this computer? That's an interesting question. No, I don't. Okay. So there's got to be a way to send stuff to a port. I mean, telnet used to do that. Is there an easier way? Good question. Linux send data to port. Let's say command line. That's kind of what I'm thinking about. Netcat. That listens to a port. I don't want to listen to a port. I want to send. I don't know. Do I have, well, let's first find out, do I have netcat? I do. So then, netcat. Let's find out how to use netcat. Quick. I don't want a port scan. I don't really want a server. TCP server and TCP client. That sounds like what I want. NC blah port number less than some text. Oh, so maybe I can just say localhost and my port number. Let's find out. NC 7001. What was the other piece? Oh, port number. Port range not valid. I don't want a port range. Man NC. So it takes a host name and ports. Is there an example? It takes a host name and a port. Why did you not work? Host name and a port. Oh, I didn't. I had an extra 0. Okay. Now, if I type something, hello. I got it back. Frogs are green. Yippee! Oh, that was weird. I got yippee back. Ah! Bingo. So, the problem is that when I read yippee, it overwrote this much of the buffer, but the and probably the R for the return, and left the E green was still there from before. And I'm printing the whole buffer. I'm echoing the entire buffer back. So it actually echoed yippee, the carriage return, and the leftover stuff. There's probably actually a lot of stuff out here that I'm not seeing. Because it's probably printing the entire buffer, all 128 characters, most of which are zeros, and so they don't show up as anything. So we have an issue. My write all isn't doing the desired thing. Now it takes a slice, so in theory I ought to be able to say 0 dot dot numRed bytes, and now I would only write back the slice of that array that is relevant. I need to restart this and restart this. Hello, frogs are green. Yippee! It seems to work now. I can type really long strings followed by shorter strings, and it still seems to work. Can hit a blank line, and that is actually sending a character. It's sending the return character, so it doesn't think that we're done. We should 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that should be 130 characters, and our buffer is 128. And it prints back correctly. And I ought to be able to like get something really big. Boom. Well, now it's I broke it. What did I do? Obviously too long, and it doesn't work. Control D should exit me out. So it successfully quit. I should actually print something over here to indicate that we started handling a client and stopped handling a client. So we can tell that the Control D is actually ending the buffer. So so let's see, we could do that just right in here. Print line, boom, boom, handling a stream. I wonder if stream implements debug. Can we print it? And is it colon question mark? I never can remember that. Yeah. Okay, so it looks like we can print a stream. I don't know what we're going to get. And here we can say print line done handling stream okay. Aha. Handling a stream, this address, that port. We're getting our stuff from localhost at that port. And if we say howdy, what's up, I'm done, Control D, we got done handling, cool. And now if I do this, so this should highlight one of the problems of not having threads. If I do that, and I do this over here, boom. Now this will not respond, whereas this is, oh, yeah, this is responding. And now when I control D here, then it finished handling one stream and immediately started handling the other, and then we got this response back. And that's because actually, let me Control C. That's because this blocks at the moment, and so we do not move on to another connection until we have actually fully handled this connection. And that's not great. We'd like to be able to handle multiple connections in parallel, which is where threads would kick in. So, but we're not solving that right this second. Okay, so that all seems to do the happy thing. Oh, it's underlining mutable stuff. I don't think I realized it did that. Well, that's kind of cool. So if there's mutation happening, it's highlighting that so that we are aware of it. That's kind of slick, actually. So let's commit what we have. See, I think that was just me changing something. Oh no, that was just me providing a little README. So that's just an implementation of an unthreaded server. Implement. Actually, I really probably ought to do the README as a separate thing. So let's add a simple README for the server. That doesn't really do much. And now implement simple unthreaded. Get rid of simple unthreaded server. This provides a working server with two significant drawbacks. Our error handling is fairly weak, and we have no threading. So we can only handle one connection at a time. Okay. And I sort of feel like I'm going to say 3. There should be proper logging added to this. So we really ought to probably have a logging library that's allowing us to log to a file with, like, I don't know, rolling logs and all the fun stuff. Because if this was a real server, you'd want to have some kind of meaningful logging going on, and we don't really have that right now. So I think that would be a thing that we would want to add. Okay, so I'm going to say go on. Actually, I'm going to copy this and add this to our boom, and we'll say boom. So 3 or several issues to deal with, and then we're gonna stage that in so that we have that comment, and then we'll commit. Huzzah. So we've implemented the server without threads. So that takes care of that. Now, so I'm actually going to push that, and I'm going to merge implement server no threads into main. So essentially I've merged the pull request without bothering making the pull request. Then I'm going to head back over to main, and I'm going to say branch implement server with threads. So let's go and do that next. What time is it? Oh, it's only 3:07. We're making good progress. That's cool. Okay, so I think we want to have threads. Threads are going to be useful. Now, or some kind of concurrency. Threads, don't really care. Now, if listener.incoming is an iterator, can we I was gonna wonder if we could use Rayon's par iter, but that's really probably not a good choice because par iter is going to need to know how many connections we have to know how to parallelize them, and down that road lies madness. So I don't think that's a good idea. I think that something where we like pull things from a thread pool. So I think that's like executors and thread pools or something. I've got to clean this up. Whoops, wrong thing. Rust, executor, thread, futures, executor. I think this is... So it does thread pool stuff. Now is that different from this? I'm not sure what the standard thing is here. Well, here, let's just be rude and go to the GitHub for each of these and see what they look like. So this looks like this is not standard stuff. Okay, let's see. It's best to select an executing implement. Best to test the exact requirements on the target hardware. The crate executor performance provides a blah blah blah. Probably don't care about that right now, but might be a thing to come back to. I don't know. I don't think we care about crossbeam stuff because I think crossbeam stuff is about using channels, and we're not doing any channel stuff. I think this is maybe overkill. So this seems to be the Russ Lang thing. So let's go with that, actually. So futures executor. We'll go with that. And so we want to do a thread pool. So we're going to need a new thread pool. Actually, how do we get a thread pool? Probably the builder. It'd be nice if we had an example here. Does this give us something? Here we go. Thread pool builder. So we're going to make a new thread pool builder. We can specify the pool size. We don't really care about most of this other stuff, I don't think. And then we would create. Okay. So we can thread pool builder. I wonder if are we going to have to like bring a crate in? I bet we are. Well, no, because this is, I don't know if we're going to need a crate here or not. Well, let's just try it and see what happens. If it yells at us, we will know that it wasn't happy. Okay, so we need a thread pool. So let thread pool equal thread pool builder, new. Actually, I probably want this up here. Dot. Well, so let's just try that. Now this is not happy, and it doesn't seem to know about it. So I wonder if we do have to add futures. Cargo add futures. Is that what it was? Futures, yes. Boom. Ooh, I needed thread pool added because it didn't do that, which I think it told me it wasn't going to do that. Available with features executor and thread pool, and I didn't add either of those. So futures executor and thread pool both have to be added. Cargo.lock. Nope, cargo.toml. That's right here. Oh, I forget. What is the syntax for features? It's something like Rust cargo.toml features. Here we go. So we have a version and dependency features. There we go. So curly brace version equals features equals square bracket list. So futures curly brace version equals comma, features equals square bracket, quotes, futures executor, can't spell, futures executor, and thread pool, thread dash pool, and then close curly brace. Okay. Now, can we import hot diggity? Okay. So we can say new dot pool size. Oh, I can leave that alone and I'll get the number of CPU cores. That's actually probably reasonable. So I wonder if just creates all I want to do. Boom. Boom. And now that's going to fail because the type of the error is different. So we could return, because create is an IO error. I thought that's what we were returning. Standard IO error versus an IO error. So they're not the same. Well, that's weird and kind of annoying. So we definitely going to have to do something about the error handling here, because this is going to be a mess. Because we now have, when we only had one category of errors, it wasn't too bad. But now that there's two of them, it's going to be a mess. So I really want, so I think I'm just going to say expect we failed to construct the thread pool. And I'm just going to do that for now. And that's not great. So we're going to want to say handle this error more appropriately. And now down here, every time we get a thing, we want to where am I? Okay, don't care about that anymore. And now we want to spawn now that we have a thread pool. What do we do with it? So it's going to be spawn something. So we said a future is going to be a thing. That seems kind of annoying. I feel like there ought to be a Hmm. So what did this do for me? No, that wasn't helpful. I feel like there's a better way to do this. Rust, process, task, thread pool, executor. Oh, we could do Tokyo as well. Heavens to Betsy. I'd forgotten about Tokyo. That could be a whole nother kettle of fish. And then we would just say thread pool spawn. And what's lazy? Good question. Function spawn. What does spawn take? Spawn takes a future. I don't know where lazy comes in. It's in futures, future, lazy. Where are futures and does Tokyo oh, that's the latest version. Try going there. Ooh. That's not helpful. Modules. Okay, let's look for pool. Thread pool scheduler. Ugh. Looks like it got more complicated somewhere along the way. Probably because it needed to, because probably all of this is difficult. Spawn function and join handle. So Tokyo task spawn. So what does that do? How does that work? Tokyo task spawn. The spawn task may execute on the current thread or it may be sent to a different thread to be executed. The specifics depend on the current runtime configuration. Okay, so this is similar to what we're interested in. So we would spawn. Okay. And this code doesn't say anything about runtime. So is the default runtime tasks running on the Tokyo runtime are always inside of runtime enter. I don't see any runtime in that code. So do we have to can we just most users will use Tokio main on their entry point instead. Is that what that other code did? Yes. Okay. And Tokio main probably is doing then the right thing. Creates a new runtime instance with the default configuration values. Most people do not need to call this directly. They will use this attribute. That looks like that might be kind of useful. So maybe Tokio, like everybody uses Tokio, so I feel like I probably ought to use Tokio, which is, if a bunch of lemmings jumped off a cliff, yada yada yada. But still, I think that Tokio probably is the thing. And so I don't think we care about the runtime feature. We do care about spawn though. So it sounds like we need the feature RT to be able to spawn a task. Oh, actually, what do we have here? Didn't we have? Oh, no, it was back here. We had the example. And so this actually has its own TCP listener. So do we need, and then maybe our error handling becomes simpler. I have a feeling maybe. Yeah. So let's try, and actually cargo help add features. Minus features, space for comma separated list of features. Okay. So cargo add Tokio minus features RT. Okay. And can I cargo help? So I can add, can I remove? No, looks like I just do that through the editor. Well, that's fine. Cargo toml. So I'm actually gonna just comment that out for the moment, and then here, okay, so let's see, all of this is going to go away for now, this is going to go away for now, and I want this to look like, so I need this Tokio main thing. We're going to have IO result. So boom, boom. And this is, so if we change this to this, that doesn't seem good. And actually, if we just make that, and then we IO. That at least makes that go away. Now, why does Tokyo main not work? That's a good question. Is there some other feature I needed? No, that is not the problem. Is this just a use thing? Okay, let's bring you back. Get rid of you. Yeah, oh, come on. Yeah, I bet I need to import something. And this didn't. Oh, right there. I bet I need. Well, I'm gonna need both of those. Maybe they'll magically make things better. No. No TCP listener in net. It's like all my Tokyo imports are broken. What is going on? Well, let's ask the internet. Rust, Tokyo, main. What's the? Could not find main. Could not find main in Tokyo. Ah, you got it. So it is a feature. So you have to have full. RT and macros. Okay. Oh, so maybe we do need the full. Yeah. I don't know. Well, or let's try this. See if we can. Oh, much less shouting. Much less shouting. Okay. Good news. Now. Okay, so we don't need thread pool builder. Yeah, we're not doing any of this thread pool stuff anymore, because that's just going to happen at the level of Tokyo. And then if we get back here, so we had TCP listener bind, await. So that's interesting. So this bind is an async. So it might need an await. But I don't get a type. probably because I'm not returning the right thing. Oh, come on. Aha! Async is missing. That's the problem. So main has to be async now. Oh, stop. Don't do that. That makes sense. And now if I move my weight out, I get what? Still don't get something that makes sense. I'm going to leave that off for a second. We'll come back to it. Ooh, why are these grumpy? Unresolved imports. So those probably require adding another feature. Modules net TCP listener requires the net feature. Of course it does. Okay, those load up now. That's a win. And now, yeah, so now we get now we get the problem of our await. So what's it being grumpy about? Question mark can only be applied to the values that implement try. The trait try is not implemented for impl future. Consider awaiting on the future, which is totally what we want to do. Wait. And now the question mark does a thing. Bingo. Okay. So now we get a TCP listener, and then we accept, and we get a socket and a something. So this doesn't support that. Yeah, so we have to just call accept directly. That's minorly annoying. I don't know what that's going to convert into. So dot try into, yeah, I don't know what that's converting into. So I think that we want to we'll just go with the loop that they have. Go away. Do. So what does accept return? It returns a pair. It's the stream and the socket address, and we don't care about the socket address, which is why we can ignore that. And then we'll await it because that can take arbitrarily long. And then we'll say echo stream and let's comment all of that out. And suggest we don't need that anymore. And echo stream. Oh, but we didn't want to do that. We wanted back up to our spawn. Where'd our spawn go? Where's our spawn? Right here. So we actually wanted to spawn waiting for the, yeah, okay. That's right. That makes sense. Because if we await here, this is going to hang until we come back. And we don't want to do that. So we want to say Tokio spawn and async move, beep, bop, boop, boop, beep. And we need to, oh, we've got an await. Okay. So that, I think, will loop, get a connection, which gives us a stream, a socket, and then we will, actually I like the idea of calling this a socket. They call it a stream in the type, which is a little weird. But I do feel like I think of it as a socket. So actually I'm going to change this to be socket. Rename symbol, socket. And now this returns nothing is what they have. But we do need to return something. So I think this probably, if we say IO result, and then this, oh, interesting. So that version of TCP stream doesn't have write all. Well, that's potentially annoying. That's that. This is TCP. No, it's TCP listener. I want a TCP stream. TCP stream. There we go. Write all. Hello. Is it that I need the await? I bet it is. Dot await. No. So this is a TCP stream, and it should have a write all. Yet we don't. Why do we not have a write all? Socket dot. Oh. None of that stuff's there. Read's not there either. Why not? What can I do with that? Into linger, peak, pull, ready, try read, try write. Come on. This claims that should be, what is async write ext? Is that a necessity? The write all method is defined on the async write ext trait. Aha. So I think I have to grab that. And I bet there's an async read trait as well that I'm going to need. And that probably is a feature that I don't have. That's in the IOUtil category feature. Okay, so I need IOUtil added to and now that works. And oh, no, read's not happy. Oh, yeah, fine. That's not happy because that's just confused. That works. So I'm guessing there is a read extension as well. So we probably have to async read ext boom bop. And they just seem to do this without spaces around the ends. And now read dot await probably await. Yeah. Except for no, not the right thing. Still something unhappy. Can only apply to values that implement try. Oh. Oh. But this returns a usize error. Oh, the problem is that this is the wrong kind of error. Right? Yeah. So I think the problem is read returns an IO result and well, IO result, that's what we want. So why is that not happy? Oh, this is not async. Come on, find my cursor. There we go. Async. That's going to fix all kinds of things. Yeah, that's better. So now I think I can put a question mark here. Yes. And now everything compiles. And this, I think, can now be just question mark because, nope. Oh, because it's in the spawn. Yeah, that's not going to work. So it's grumpy because we're not checking the error. Well, let's just let result be that. And then we'll just say oh no, we'll just put an expect on that. That's what we'll do. Dot expect there was a problem handling socket. Boom. And we've got a that's because this is format. So format bang and now this is going to be grumpy because it really just want to borrow that. Oh, right. It's the into problem. No. It's star. And then into. Oh. Okay, fine. Let's just decide we don't care that much. Because we got to do, there's a lot about the error handling that's wrong. So let's just get that to work. Okay. So, we need to do that. We've got a question mark here to do handle errors when accepting requests, and we need to handle this error to do handle error when processing socket. And here we've got a question mark there. Handle error when reading from socket. And yeah, okay. So in theory this compiles, does it work? That'd be a great question to ask. Cargo run. Oh yeah, we gotta download all of Tokio. And now blah blah blah. Boom boom. So that looks good. Can I connect the second one? Can, and I can use them in parallel. And we have two connections at two different sockets, and if I close this was the first one I made. So yep, the first one just got closed. The second one is still alive. Close it. I close them both. Bingo. Okay, so I think we have a threaded version, and it's 4 minutes for the end of the session. So, of course, we had to do a complete rewrite to get to bring Tokio in to deal with the threads. But once we had done that, then it wasn't too bad. So I think that's pretty reasonable. And yeah, I think we're in a pretty reasonable place. So I think commit and push, and we should be good. And then when we come back to this, let's see. So I guess we can get rid of this. That's been dealt with. I think actually when we come back to this in a week, my inclination is going to be to actually deal with the error handling and the logging, because I think that those would be useful to do here. And then once those are dealt with, then the client, I think, will be really straightforward. I think the once we've got all the pieces in place for the server, I think the client will be a bit of a no-brainer. So I guess I don't need features anymore, so I should make that go away. And I don't know how many features there are. Oh, there were a lot when we loaded that. Yeah, there are a bunch. So there's a lot I'm not using. So it's probably still better to just use the ones that I need. So I think that's cool. Okay, then I'm going to commit, and then we'll call that a thing. Oops, I don't want that. So we've replaced, no, we just added Tokyo because we had futures, but we never committed that. Oh, we got some commented out stuff here. We should clean that up. And actually, I'm going to leave this IO result because I'm always confused about which result we're talking about at any given point. And if we have IO result, that makes me a little happier, actually. So, okay, so this is all bringing in Tokyo stuff, and this is turning main into an async and adding the Tokyo main, changing to Tokyo's asynchronous listener, changing just to an infinite loop. Kind of missed the for stream, actually. That was kind of nice, but we'll live. And then made this asynchronous, changed the name stream to socket everywhere, and added all these awaits. Yeah, okay, I think we're good. So add threading to server with Tokyo. This brings in Tokyo to make the main and echo stream functions async, and provide the ability to spawn threads to handle incoming connections. Can't spell. Okay. I think that's good. I'm going to commit that. I'm, right after 4 o'clock, so I'm going to quit. Thank you all for coming. I appreciate your time and your attention. Hopefully that was useful. We will return to this project a week from today, from 2 to 4 again. Reminder that Tuesday and Saturday mornings from 10 to noon, going over building a web app using Rust and U to archive GitHub repositories, and also Wednesday nights from 7 to 9 p.m. Central Daylight Time, doing evolutionary computation and implementing evolutionary computation systems in Rust. So, thanks for joining me. My schedule here on Twitch should have all of the relevant times and dates. So thanks a lot for joining me, and I will talk to everybody later. Ciao!